my name is Mr. Sam and I'll be your mathematics teacher today. In this video, I'll be taking you indices. One of the most simplest topics in mathematics, indices. So what I'll try to do in the next couple of minutes is to cover the laws of indices and also take a few examples. And at the end of this video, I'll be giving you practice questions to go and fill it. So we'll start with the first rule of indices. Okay, before I start, let me emphasize this. When you have a number raised to a power, this number is referred to as the base. So when I'm saying base, you should know what I'm talking about. And then this here is the power or index. The plural of index is indices. So basically, in the topic of indices, we are dealing with powers. So the first rule states that if you have x raised to power a times x raised to power b, where the bases are the same, whether the powers are different or the same, in as much as they are multiplying, the rule of multiplication states that they are going to add the power together. So that will be x to the power a plus b. That's simple as this. So let's take, for example, we have 2 raised to the power 3 times 2 raised to the power 2. This will simply become 2 raised to the power 3 plus 2, and that is 2 raised to the power 5. 2 raised to the power 5 will be 2 times 2 times 2 in 5 places, and that should give us 32. That's a very simple one. Any of you should be familiar with that. Now the next one is the rule of division. If we have x raised to the power a, this time around divided by x raised to the power b, if they are multiplying, we add the power. When dividing, all we do is to subtract the power, and that will be x raised to the power a minus. So let's take, for example, we have 10 raised to the power 15 divided by 10 raised to the power 12. What we do here is simply say 10 raised to the power to subtract, we have 15 minus 12, and that is 10 raised to the power 3. 10 raised to the power 3 is 10 times 10 times 10, and the answer is 1000. Those are the first two very, very simple indices. Now let's do the second one, the third one. Now this one is when you have an index of 0. When you have x raised to the power 0, the power, whenever it is 0, whatever it is that is taken to the power 0 will become 1. E.g., if you have 2 raised to the power 0, that's 1. If you have 100 raised to the power 0, that is 1. Whatever it is raised to the power 0. So I will not waste time on this. I hope that is what's it. Now let's go to the next rule of indices. That is number 4. Now for this number 4, I'll be looking at the rule where we take a power to another power. For example, if we have x raised to the power a and then x to the power a is taking power b, what do? We simply multiply the two powers. Like this, that will become x raised to the power a times b. That is x to the power ab in this case because you can't multiply more than b. Now let's say we want to look at real life cases. Like x raised to, let's say, okay, let me see if I have 2 raised to the power 3 raised to the power 2. That will become 2 raised to the power 3 times 2, and that is 2 raised to the power 6. 2 raised to the power 6 will give you 64, and that's the answer to that. Now we'll take the next one dealing with roots. When you have roots, for example, the roots of x. Now the thing about roots is that when it is square roots, they don't write any number here. But if it is cube roots, you start seeing 3. If it's 4, you start seeing 4, and like that. So when it is not having anything, we say it is square root. But for this example, I'll be using a. So let's say we have a root of x. So this simply means x raised to the power 1 over a. So where we have the root, it becomes this. E.g., if I have the square root of 4, I can write the square root of 4 as 4 raised to the power 1 over 2. Now to simplify this further, I can make use of this law up here and take 4 to index form. An index form 4 is 2 raised to the power 2. So bringing it in here, that will be 2 raised to the power 2, but it is carrying power 1 over 2. So all I do with the two powers now, I'll multiply based on this rule, and that will become 2 raised to the power 2 times half. 2 times half is 1. So our answer will be 2 raised to the power 1, which is 2. That's the next one. Now we'll go to the next one where we have negative indices. That is negative powers. If you have x raised to the power minus a, that will be equal to 1 over x raised to the power a. That's simple as this. Where the power is negative, we take the minus as 1 over the number still takes the power, but the minus won't be there again in the denominator. Mind you, if I am too fast, you can always rewind. I'm doing this so that I'll cover much in a smaller amount of time. So e.g., let's say we have 5 raised to the power minus 2. That will be equal to 1 over 5 raised to the power 2. And what is 5 raised to the power 2? 5 squared, that is 25. So that is 1 over 25. That's the answer. Now, these are a few rules of indices. Any other thing is actually gotten as a multiplication or combination of these rules together. What we'll be doing next now is that we're going to consider some simple questions using these rules as case studies. So now, if you're taking notes, I believe you are done by now, or if you have not, quickly go back and check it because I'll be playing this off now. So I'm going to consider the following example, say simplify the following. So these are the questions we want to solve right now. The first one. We have 16 raised to the power minus 1 over 2. How do I approach this? You see this negative power there. Remember from the rules, we said that would be 1 over then 16 raised to the power half. So now if you look at the number 16, we can take it to index form. Normally, students will jump from here because they know that okay, power half means the square root. If 4 raised to the power half is the same thing as the square root of 4, so they just jump from 4 raised to the power half is equal to 2. Why this is not wrong, it is not wise to do this in an exam where you are supposed to solve the indices. You're supposed to follow the rules and not just jump because you know. So instead of jumping and saying this is square root of 16, which is 4, I'll take 16 to index form. I can use 2 raised to the power 4 is 16, or I can use 4 raised to the power 2. This will help me eliminate this easily. So I'm going to be using 4 raised to the power 2, then raised to the power 1 over 2. That is 1 over 4 raised to the power 2 times half. 2 times half is 1. So basically I have 1 over 4, and that is my final answer. Number 2, I have 3x squared times 5x raised to the power 16. Now, what do we do? You see these numbers are here, multiply them normally. But for these ones that are the same basis, we will apply the rule of indices for the power. So I can say we have 3 times 5 times x squared times x to the power 6. 3 times 5 is 15 times x to the power. Because they are multiplying, we add the power. That is 2 plus 6. That is 15 times x to the power 8. And our answer will be 15x raised to the power 8. It's as simple as this. Now, number 3 question, we have 27y raised to the power 4 divided by 9y. That is 27y raised to the power 4 over 9y. I write it this way. So what is 27 divided by 9? 3. They all due to the powers of y. We'll subtract. Y by standing alone, because no power is written there does not mean that the power is 0. The power of y here is 1. If it is y raised to the power 0, that is 1, and they won't even write it at all. So if it is written alone, then the power is 1. So we subtract the power, that is y raised to the power 4 minus 1. And our answer will be 3y raised to the power 3. That's that. So that's very, very simple. Number 4, we have 1 over 4 raised to the power minus 1 over 2. Now, for this one, I can solve it in different ways. Now, one trick that I know that works, let me just use operation to tell you. If I have a over b raised to the power minus c, you can take note of this. I can remove this minus by just swapping the positions of the members of the fraction. b will come up, a will come down, now b over a raised to the power c. Automatically, the minus goes. Basically, the minus is telling you that it's inverse. So we can invert it and remove the minus. I hope that's taking note of. Now, I can do the same thing here and just say I have 4 over 1 raised to the power 1 over 2. I hope you get it. Now, if you didn't get it, just go back and check it again to understand. But that's not what I'll do here. Now, what I will do is I will take this one using the rule of indices. I know that this is 4 raised to the power minus 1. The minus is from the 1 over, and this is just for 4 raised to the power 1. So now raised to the power minus 1 over 2. Following the rule of indices, I can multiply the two powers and I have 4 raised to the power minus 1 times minus 1 over 2. Minus times minus is plus. 1 times half is half, and I have 4 raised to the power half. And then if I take 4 to index form, that is 2 raised to power 2. 2 we multiply half, 2 times half is 1, and my answer is 2. I hope that is clear. So we're going over to the fifth one now, number 5. We have 1 over 16 raised to power 3 over 4 plus 5 into 9 raised to power 0. Now let's do this. I can take 16 raised to power minus 1 because of the 1 over that's here. So that is the this. Now everything is carrying power 3 over 4 plus, now I have 5 into bracket 9 raised to power 0. We know that anything raised to power 0 is 1, so that will be 1. So now we multiply these two powers and we have 16 raised to power minus 1 times minus 3 over 4 plus 5 times 1, 5. Mouse times plus 1 times this is the same thing, so I have 16 raised to power 3 over 4 plus 5. Now to simplify this guy further, I'll have to take 16 to index form. In index form, 16 can be written as 2 raised to power 4. Now I have 2 raised to power 4 that is now carrying power 3 over 4 plus 5. So multiply these two powers and we have 2 raised to power 4 times 3 over 4 plus 5. We multiply this, 4 can cancel 4. So we have 2 raised to power 3 plus 5. 2 raised to power 3 is 2 times 2 times 2. And that is 8 plus 5. And the answer is 13. See the question, see the answer. Isn't math interesting? So this is the solution to the examples I've given. I hope you were able to learn 1 or 2. I can't make the video too long, even though there will be subsequent ones later on. The video is meant to just introduce you to my classes and then remind those that might have forgotten 1 or 2 about this. So this is what I'll do now. I will drop a series of questions, a few questions, and then you will be expected to submit the answers in the WhatsApp. Mind you, the difficulty level might be different from this. It is meant to help you to think more. So I'm going to give you a few questions as exercises. So you have to simplify the problem. Number 1. So we have 16 raised to power half times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 times 81 raised to power minus 2 over 3. Number 2, we have 9 raised to power 1 over 2 times 27 raised to power 2 over 3 divided by 64 raised to power 2 over 3. Number 3, find something. Okay, so we have 2 divided by 64 over 125 raised to power minus 2 over 3. Let me find one more, something very simple. So I'll call this number 4. I hope it is clear. That will be 27 times 2 raised to power 0 times 3 raised to power minus 2 all over 4 raised to power minus half. So you can practice with these questions, although there might be difference in difficulties. But if you can solve this, you have learned what I want you to learn for this class. Indices is broader than this. There are initial equations, there are equations where you have to apply the remedy. So this is just for the free class. Thank you very much for watching.